Decide whether the relation is a function. State the domain and range. This graph is a relation because it represents all the ordered pairs that make a certain equation true statement. So it's a set of ordered pairs. Now, this relation is a function if for every x on the graph or in the ordered pairs, there's exactly one y that corresponds to it. Now we can show this on a graph using the vertical line test. Is that a vertical line drawn anywhere on the graph will touch the graph at exactly one point. So if x is -2, for example, if I draw a vertical line through x is -2, it touches the graph at exactly one point. Now, no matter what x I choose, say if x is -6, I draw a vertical line, it's going to touch the graph at exactly one point. That tells us that this relation, or this graph, represents a function. Now, the domain of the function talks about what the x values are doing. That is, how the graph extends to the left and to the right. Well, it goes infinitely to the left. It keeps going to the left. It doesn't stop, very gradually in this case, and very gradually to the right. So for the domain, it's -infinity to positive infinity. There's no start or stop values when we go from the left to the right. Now the range deals with the y values. It's how our graph moves up or down. So I see that there's a definite point here, a definite point. So where the graph starts. So if you're coming from the bottom going up, it stops right at that point. That point is when x is -4, y is 8. So for the range, it just keeps going -infinity. If it keeps going or coming from -infinity, there's no bottom to this graph. But there is a top. It stops when the y value is 8. And the range deals with the y values. We use the square bracket because it can equal 8. It just doesn't go beyond 8.